Now we will start our matching bioassay method. We have placed our all different concentrations of the histamine stock solution to the guinea pig ileum. Now, but after that we will wash our tissue. We will wash our tissue so that no remains of the previous drug solution is present on the guinea pig's ileum. After that, again we'll prepare a baseline so that we can differentiate between the different concentrations. Now, as we can see, these are the graphs of the different concentrations of the histamine stock solution. Now, we will put the 0.4 ml concentration of the histamine stock solution again to the guinea pig ileum. And why we are doing this, we will discuss it after performing this. But at first, we will place the 0.4 ml concentration of histamine to the tissue. And after that, we will wash it. We will wash it twice so that no remains of the previous drug solution is present. And again, after that, we will prepare a baseline. The baseline preparation takes for 30 seconds. As we can see, the timer goes and 30 seconds is done and the baseline has been prepared. Now we can see the different concentrations of the histamine stock solution is drawn. Here we can see the calculation part. As we can see, this is the graph drawn, and here we have a scale through which we can record and measure the height of the graph. As we can see here, this is the scale through which we can measure the height of the graph, and here we have our observation table of the histamine of this experiment. As we can see, this contains the concentration of histamine. This contains the amount added in the student organ bath of the histamine and concentration of histamine in student organ bath, which is also filled with different solutions, and then response recorded by the movement of the frontal lever, and then response and the percentage of the response. So after measuring it, as we can see, we can move it and we can record and measure the height of the curve, as we can see, and then we can manually enter the value here, the response, as we can see. Then again, we can measure the height of the second graph. It moves. As we can see, the scale moves. And with the help of this, we can measure the height at 16. So we can add here 16. And then like that, again, the same, we can measure it. Measure the height of the third graph, which is this much. So we can place the value over here. And like similarly like that, we can measure our next and we can enter our next value. Like that, similarly, we can measure height of the next graph also. Like that, we can place all the responses manually over this table, and then after that, we have to enter the maximum value over here to prepare a graph. As we can see, we have the make graph button, and then we can save this observation for our further requirement of this experiment. Now, after that, let's see the graph of this experiment. Here we have our DRC of the histamine and matching bioassay method. DRC is the drug response concentration. As we can see, we have performed the DRC of the histamine solution, standard solution. So, as we can see, this is the graph. This is the graph of all the observations that we have recorded. The 0.1 ml concentration, 0.2, 0.4, 0.8, 1.6, 3.2, and 0.4 ml concentration of the histamine. So till the 0.4, we have the DRC of the histamine solution. We have also written the height that we have measured from the scale here. As we can see, the 0.1 ml has shown the 7 millimeter concentration contraction, and graph of the height is 7 millimeter. Then 0.2 has shown 16, 0.4 has shown 22, 8 has shown 34, and as well. So as we can see, the 1.6 ml concentration of histamine has the highest height of the graph, the 42 millimeter. It is the maximum height. And for confirming, again we have placed another another concentration which is a 3.2 ml concentration and has shown the same height, the 42 millimeter. And this is known as the ceiling effect. What is the ceiling effect? The ceiling effect is the confirmation of the value observed so that no differ can be observed. As we can see, this is the ceiling effect. The same height is observed on increasing the concentration. So this confirms that this is the maximum response recorded of the histamine solution, which is the 1.6 ml. And the 3.2 is the ceiling dose, which confirms that the 1.6 is the highest dose. And then after that, we have placed the zero point 0.4 ml concentration. Now, why we have placed the zero point 0.4 ml concentration? As we can see, the zero point 0.4 ml is the submax dose. What is the submax dose? The submax dose is that dose which is greater than the first concentration, the lowest concentration, which is our zero point 0.1 ml concentration, and and is which is less than the highest concentration, which is the 3.2 ml concentration. So the zero point 0.2, zero point 0.4, and zero point 0.8 these are the submax dose. And why we have selected zero point 0.4 ml concentration? Because it shows a greater difference of the graph from the lowest concentration and the highest concentration. As we can see, it is very greater than the zero point 0.1 ml concentrations graph, and it shows a great difference from the 3.2 ml concentrations graph. So that's why we have selected the zero point 0.4 ml as the submax dose. And it confirms that after putting the zero point 0.4 ml, after all these concentrations, it shows the same height. As we can see, the 22 millimeters shows the same height of the same concentration. Now, Now, now we will put the test drug solution to the guinea pig's ileum. Our test drug solution is also the same solution, which is our histamine solution. But our test drug solution is of unknown concentration, as we have known that the standard drug solution, as we can see, this is the standard drug solution and this is the test drug solution. So the standard drug solution, we have the known concentration, which is of the 10 microgram per milliliter. But of the test drug histamine solution, we have unknown concentration, and that we are going to find out with the matching method. Now we will place our first test drug solution, which is the zero point 0.1 ml concentration of the test drug solution. With the help of this micropipette, as we can see, this is the test drug solutions holder and test tube. We are using the different micropipette so that mixing of the test drug and the standard drug is not seen. Now we'll record the response for 60 seconds. As we can see, the timer is running and the response is recorded with the help of the movement of the Sherrington revolving drum. Then after recording the response, we will wash our tissue and we will wash it twice so that no remains of the previous drug solution is present. And we can add a new drug solution. And after that, we will perform a baseline so that we can differentiate between the different concentrations of the histamine solution. As we can see here, this is our small graph which is prepared from the zero point 0.1 ml concentration of the test drug. Now we will add the zero point 0.2 ml concentration of the test drug solution. With the help of the test drug's micropipette, we'll place the zero point 0.2 ml concentration of the test drug to the guinea pig's ileum. And then after that, we will record the response for 60 seconds. Now we will record it with the movement of the Sherrington drum. As we can see, the timer has started and the recording of the response has started. And with the movement of Sherrington drum and the movement of the frontal lever upward and downward, we will record the response of the zero point 0.2 ml concentration of the test drug. Then after that, again, we will wash it. We will wash it twice so that no remains of the drug solution is present over there. And then again, we will perform a baseline. The baseline preparation takes for 30 seconds. As we can see, this is the zero point 0.2 ml concentrations graph of the histamine solution, of the test solution. Now, we will see the graph. As we can see, this is the zero point 0.1 ml concentration of the histamine solution, and this is the zero point 0.2 ml concentration of the test drug solution of the histamine. This is the T1 test 1 solution test dose. It is also of histamine, and T2 is also of histamine, but 0.2 ml. We have recorded the height and we have written it over here. The first one shows the 4 millimeter, and the second shows the 12 millimeter height. As we can see, this is our second test drug solutions graph. And now we will see the graph over here. As we can see, this is a second test drug solutions graph, and the second test drug solutions graph and the first test drug solutions graph, as we can see, this is a 4 millimeter, and it has should been greater than the first concentration of the standard solution, the zero point 0.1 solution of the standard histamine solution. But as we have observed, the graph is slightly smaller than the first concentration of the known histamine, the standard histamine. The test first has shown a smaller graph. That's why we have performed the second test drug solution, which is the of the 12 millimeter. So as we can see, this is greater than the first concentration, which is of 7 millimeter, and it has shown 12 millimeter. Now, again, we will place the zero point 0.1 ml concentration of the standard histamine stock solution to the guinea pig's tissue. As we can see with the micropipette of the standard solution, we will place the zero point 0.1 ml concentration of the histamine stock solution. And then again, we will record the response. The response recording is taken for 60 seconds. As we can see here, we will record the response for 60 seconds, and after that, again, we will wash our tissue so that no previous drug is present on the tissue. We will wash it twice, and then after that, we will prepare a baseline, and the baseline preparation takes for 30 seconds. We have prepared our baseline. As we can see, this is the graph of the base of the zero point 0.1 ml concentration of the standard solution of the histamine. In the graph also here, we have measured the value. As we can see, this is the standard one solution, the zero point 0.1 ml solution graph, which is of the height of 7 millimeter. We have measured it from the scale as we have seen earlier, and the zero point 0.1 ml of the standard solution shows the same height, the same graph, 7 millimeter and the 7 millimeter, as you can see. But it is shorter than the test drug solution second concentration. As we can see, the zero point 0.2 ml of the test drug solution has a larger graph than the first concentration of the standard solution. It is of the 12 millimeter, and it is shown 7 millimeter. So now we will estimate the value of the standard solution to match the value of the test drug solution. So the zero point 0.1 has shown 7 millimeter. So we will increase the solution of the standard to 0.15, and then we will see what the graph shows. Now we will add the 0.15 ml of histamine solution. It is an estimated dose to match the value of the test drug solution. We will place the standard solution of 0.15 ml to the Guinea Pig Ileum, and then we will record the response. The response time is taken for 60 seconds. With the movement of the frontal lever upward and downward and the Sherrington rotating drum, we will record the graph. As we can see, the timer has started, and then we will record the response. Then after that, recording the response, we will wash our tissue so that our tissue is left with no drug solution and it is clean. And then again, we'll prepare a baseline, and the baseline preparation takes for 30 seconds. As we can see, this is our graph of the 0.15 ml concentration of the histamine stock solution. So as we can see, this is the 0.15 ml of the standard solutions, and it has shown the graph of height 12 millimeter. So it matches the second dose of the test drug 0.2 ml, and it has also the same height, the 12 millimeters. So both of these graphs have the same height and shows the same response. And this is known as the matching bioassay method, and of the through which of a solution of the known concentration we have find the concentration of the unknown solution. So with the help of with the standard solution of the histamine of known concentration of 10 microgram per millimeter, we have find the we have find the concentration of the unknown stock solution of histamine, which is also known as the test dose. So the 0.15 ml of the standard solution matches the height of the graph of second test drug solution, which is of 0.2 ml, which also shows a 12 millimeter height. This is known as the matching bioassay method, and with the help of this, we have find our unknown concentration of the test drug solution. Now we have completed our experiment. Now, let's just see the result of this experiment. The result of histamine's bioassay using Guinea Pig Ileum typically includes a concentration-dependent increase in the contraction of the ileum as histamine is administered. The response is measured by recording the amplitude or frequency of muscle contraction at various histamine concentration. A clear dose response curve is often generated showing the relationship between the histamine concentration and degree of contraction. The potency of histamine can be determined by the minimum concentration required to elicit a noticeable response. Additionally, if antihistaminics are tested, the inhibition of contraction at varying doses of the antagonist can be evaluated to assess its efficacy in blocking histamine's effect. The above paragraph explains that this bioassay of histamine by using guinea pig ileum includes the concentration dependent increase in the contraction of the ileum as histamine is administered, which means as we were administering different concentrations of histamine. See, as we can see, these are the different concentrations of the histamine. The different response and the amount of contraction was also different for the different concentrations. As we can see, this is the response recorded, and the percentage of the response is also recorded. You can see the different percentage responses of different concentrations of histamine, and a clear dose response curve is also generated. And the relationship between histamine concentration and the degree of contraction is also seen. The potency of histamine is determined of unknown solution, which is required a noticeable response. And additionally, if antihistamines are tested, which means antihistaminic drugs are tested, the inhibition of the contraction at various doses of the antagonist can be evaluated to assess the efficacy in blocking histamine's effect. Now let's see the discussion. The discussion says that the guinea pig ileum biopsy effectively measures histamine's ability to induce smooth muscle contraction, demonstrating a dose-dependent response. This assay is valuable for assessing histamine's potency and evaluating the effectiveness of antihistamines. The variations in results can arise due to factors like tissue preparation and experimental conditions. Despite newer techniques in pharmacology, the bioassay remains a reliable method for studying histamine's physiological effects and the efficacy of histamine-related drugs. The above paragraph says that this bioassay method is effectively measures the histamine's ability to induce smooth muscle contraction and demonstrates a dose-dependent response. And it is valuable for assessing histamine's potency and effectiveness of the antihistaminic drugs. And variations can also be seen due to the different factors which affect the experiment, such as tissue preparation and experimental conditions such as temperature, moisture, and the conditions of the instruments. Despite newer techniques of the pharmacology, this bioassay method remains a reliable method, which means this is a reliable method for knowing the physiological effects of the histamine drugs and efficacy of histamine-related drugs. Now we have completed our experiment, and I hope that you have learned a lot in this experiment. As we can see here, this is a quick guide and the steps to perform this experiment, the procedure part, the principal part, and the introduction part. You can download the user manual also before performing the experiment. As we can see here, this is the user manual through which we can perform and we can read the experiment before performing the experiment.